NEC 230.40 and 230.71 place restrictions on the number of service disconnecting means permitted for a single set of service entrance conductors grouped at one location. The question at hand involves a single building with 8 separate addresses, each individually metered and separated by fire-rated walls. The key consideration is whether this situation representing multiple occupancies affects the applicability of the NEC limits. The answer is yes. NEC 230.40 and 230.71 do apply to a single building that houses multiple occupancies. Let's examine these code sections more closely. NEC 230.40 explicitly states that the service disconnecting means must consist of no more than 6 switches or circuit breakers grouped at any one location. This is a fundamental rule to ensure clarity and safety in electrical systems. NEC 230.71 further elaborates on scenarios involving multiple occupancies served by a single service disconnecting means. It mandates that in such cases, the service must be subdivided into no more than 6 service entrance conductors. This provision aims to manage the complexity of electrical distribution in buildings with several tenants or units. In this specific case presented, the building's configuration with 8 separate addresses, individual metering, and fire-rated walls qualifies it as a multiple occupancy building within the scope of the NEC. Consequently, the rule outlined in NEC 230.40 and 230.71 is fully applicable. The practical implication is that the entire building cannot have more than 6 service disconnecting means in total. This limitation is irrespective of the number of individual occupancies or meters within the structure. It's crucial to acknowledge that multiple occupancies within a single building significantly influence the interpretation and application of this rule. The code is deliberately designed to limit the number of service disconnecting means for sound reasons, primarily to prevent confusion and mitigate potential safety hazards. In a building accommodating various occupancies, it's paramount to establish a clear, easily understandable, and readily accessible system for identifying and accessing the service disconnecting means for each specific occupancy. Consider the potential dangers of having numerous service disconnects scattered throughout a building. During emergencies such as electrical faults or fires, quick and accurate identification of the correct disconnect is vital. A multitude of disconnects can lead to delays, misidentification, and increased risks for both occupants and emergency responders. The 6 disconnect rule promotes a more organized and manageable electrical system, reducing the likelihood of errors and enhancing overall safety. Now, let's explore some practical implications and scenarios related to this rule. Firstly, in the design phase of a new building with multiple occupancies, electrical engineers and contractors must carefully plan the service entrance and distribution system to comply with the 6 disconnect limit. This may involve using main service panels with multiple subfeeds or employing other approved methods to distribute power while adhering to the code. Secondly, for existing buildings undergoing renovations or expansions, it's essential to reassess the service disconnecting means to ensure compliance. If the existing configuration exceeds the 6 disconnect limit, modifications will be necessary to bring the system into compliance. Thirdly, regular inspections and maintenance are crucial to verify the integrity and functionality of the service disconnecting means. This includes ensuring that each disconnect is properly labeled, easily accessible, and in good working condition. Ignoring the 6 disconnect rule can lead to various consequences, including code violations, fines, and potential safety hazards. Electrical inspectors are responsible for enforcing the NEC and will issue citations for non-compliance. Moreover, insurance companies may deny coverage for damages resulting from electrical incidents caused by code violations. The most serious consequence, however, is the increased risk of electrical fires, shocks, and other hazards that could endanger lives and property. It's important to note that the NEC is a comprehensive set of standards that evolves over time to address new technologies and emerging safety concerns. Electrical professionals must stay updated on the latest code revisions and interpretations to ensure compliance. Continuing education, training courses, and professional certifications are valuable resources for staying informed about changes in the NEC. Now let's delve a bit deeper into the technical aspects of service disconnecting means. A service disconnecting means is essentially a switch or circuit breaker used to isolate a building's electrical system from the utility power supply. It serves as a crucial safety feature, allowing electricians and emergency responders to de-energize the system for maintenance, repairs, or in the event of a fault. The NEC specifies various requirements for service disconnecting means, including their location, accessibility, and rating. The disconnecting means must be readily accessible to occupants and emergency personnel. It should be installed in a location that is free from obstructions and clearly marked. The rating of the disconnecting means must be sufficient to handle the maximum available fault current at the service entrance. This is a critical safety consideration to prevent the disconnect from failing under fault conditions. The NEC also addresses the coordination of overcurrent protective devices, such as fuses and circuit breakers, in the service entrance. Proper coordination ensures that the overcurrent device closest to the fault will trip first, minimizing the extent of the outage and preventing damage to equipment. In buildings with multiple occupancies, the service disconnecting means for each occupancy must be clearly identified and labeled. This allows occupants and emergency responders to quickly locate the correct disconnect in case of an emergency. The labeling should be durable and easily readable, even in low light conditions. Some jurisdictions may have additional requirements for service disconnecting means, such as requiring the installation of surge protective devices to protect against voltage spikes. It's essential to consult with local authorities and electrical inspectors to determine the specific requirements in your area. When selecting service disconnecting means, it's important to consider the specific application and the electrical load requirements of the building. Factors to consider include the voltage, amperage, and interrupting rating of the disconnect. It's also important to choose a disconnect that is suitable for the environmental conditions in which it will be installed. For example, in damp or corrosive environments, a disconnect with an M4X rating may be required. Regular maintenance of service disconnecting means is essential to ensure their reliable operation. This includes inspecting the disconnect for signs of damage, such as cracked insulators or loose connections. It also includes testing the disconnect to verify that it trips properly under fault conditions. Any damaged or malfunctioning disconnect should be replaced immediately. Now let's discuss some alternative approaches to complying with the 6 disconnect rule in buildings with multiple occupancies. One option is to use a single service entrance with a main service panel that feeds multiple sub-panels, each serving a separate occupancy. The main service panel would contain the primary service disconnecting means, while the sub-panels would provide additional overcurrent protection and disconnects for each occupancy. Another option is to use a series of service laterals, each serving a limited number of occupancies. Each service lateral would have its own service disconnecting means, but the total number of disconnects would still need to comply with the 6 disconnect limit. In some cases, it may be possible to obtain a variance from the local electrical inspector to exceed the 6 disconnect limit. However, this typically requires a detailed engineering analysis demonstrating that the proposed design provides an equivalent level of safety. It's important to remember that the primary goal of the NEC is to protect people and property from electrical hazards. The 6 disconnect rule is just one of many provisions designed to achieve this goal. By understanding and complying with the NEC, electrical professionals can help ensure the safety of buildings and their occupants. In summary, when dealing with a single building that houses multiple occupancies, NEC 230.40 and 230.71 strictly limit the number of service disconnecting means to a maximum of 6. This limitation is put in place to minimize confusion and potential safety hazards. Therefore, it's critical to adhere to this rule while designing, installing, or modifying electrical systems in such buildings. Always consult the latest edition of the NEC and local regulations to ensure full compliance.